This video will explain how to upgrade your smart contracts using the Zeppelin upgradable contracts. Before we get started, let's review how an upgradable contract works. Here I have what's called a proxy contract. This is a contract that the users will call. And on the right, we have a contract called implementation. These are the contracts that can be upgraded. A user sends a transaction to the proxy contract. The proxy contract executes the fallback function, and it delegates call to the implementation contract. This means that the code inside here will be executed using the state variables inside here. Later, let's say that we deploy a version 2 of the implementation. Then we can upgrade the smart contract by routing all transactions from the user to version 2 instead of version 1. This is how a combination of proxy, fallback, and delegate call enables contract to be upgraded. The proxy contract will have a function to upgrade the implementation from B1 to B2, and we probably should restrict the access to this function call. Only the admin should be able to call upgrade. For our example of implementing the upgradable contract, we'll be using Zeppelin. And when we use Zeppelin for our upgradable contract, it deploys 3 contracts: a proxy, implementation, this will be our custom logic code, and a contract called proxy admin. This will serve as an admin to this proxy contract, so that if we are the admin of the proxy admin, we will be able to call the function upgrade inside the proxy admin, and this will forward the function call over to the proxy contract. This is done for a security reason which I will not discuss in this video. Further details about the security, I'll put a link in the descriptions below. Okay, let's build a simple upgradable contract using Zeppelin library. Here I have an empty folder with package.json. And here are the npm libraries that you will need to install: Hardhat, Ethers, and some Hardhat plugins. Hardhat plugin for upgradable contracts, Hardhat Etherscan to verify smart contracts on Etherscan, and Hardhat Ethers to use Ethers with Hardhat. We also install some contracts from Zeppelin, Zeppelin/contracts and contracts upgradable. We won't be using these packages in this video, but in another video, I'll show you how to create an upgradable ERC20, and we'll need these contracts. Open the terminal and install the packages, npm-i. Once the packages are installed, we'll initialize a Hardhat project inside this folder by typing npx hardhat, and we'll create a basic sample project. Once that is done, you'll see some folders being created by Hardhat. The first thing that we'll do is create some upgradable contracts. So inside contracts, I'm going to delete the sample contract that was created by Hardhat. And then inside here, I'll create 2 contracts. I'll name this box.sol and also version 2 of this contract, box b2.sol. Box.sol will be our first version of the smart contract. For this example, we'll be using a very basic, simple example. The only state variable that it has is a uint, and the only function that it has is called initialize, which sets val to the input. Now notice that I have commented out the constructor. This is because for upgradable contracts, the state variables inside the implementation are never used. We'll talk more about this in another video. For now, just remember that we can't have any constructors for upgradable contracts. So this is version 1 of the box contract, and this is version 2 of the box contract. This is the contract that we're going to be upgrading from version 1 box to version 2 box b2. It still has the same state variable in the exact same order as version 1. Unlike the version 1 contract, this contract now has a new function called inc, and it increments the state variable val. Also notice that we have commented out the function initialize. This is because this function initialize is only called once when the first version of the contract is deployed, so in the second version, we won't need this function anymore. Once you have some contracts to deploy, the next thing that we'll do is write some script. A script to deploy version 1 of box, and a script to upgrade to version 2. And before we can do that, we first need to configure hardhat config.json. I'll remove all of the extra stuff that we don't need. The Solidity version that we're working with is 0.8.10, so I'll change this to 0.8.10. We're also going to need some plugins, Ethers, upgrades, and EtherScan. For this example, we'll deploy our smart contracts to the Robson test network, and for the Ethereum provider, I'll be using Infura. And we'll provide our Infura API key and the private key that will be sending transactions from the environment variable. And lastly, to verify smart contracts, we will also provide the EtherScan API key from the environment variable as well. We will create a .m file to load the environment variables. The environment variables that we'll need to load are Infura API key, EtherScan API key, and the private key to send the transactions from. Once that is done, we will now create a script that's going to deploy the version 1 box contract. So inside the scripts folder, I'm going to remove the sample script that was created by Hardhat, and then create a new script called deploy box b1.js. Inside deploy box b1.js, the first thing that we'll do is import some libraries from Hardhat, ethers, and upgrades. Next, I'll write an async function called main, and inside here, we'll write our code that's going to deploy version 1 of box contract. Using ethers library, we'll get the smart contract by calling get contract factory. And we'll deploy our version 1 of box contract by calling deploy proxy on upgrades. Now notice that we're passing in some parameters. The function that we're going to be calling on the box contract when this contract is deployed is called initialize, and the parameters that we'll be passing is 42. If we go back and take a look at the box contract, the function that we're going to be calling is initialize, and the parameter we're going to be passing in will be 42. Once we call deploy proxy, we'll need to wait for all of the transaction to be mined. So we'll call box.deployed. Once this is done, we'll log the address of the box contract. Let's execute this script and we'll deploy version 1 of box contract. And be sure you filled out .m file. Inside hardhat.config.js, I'm going to remove the first plugin because it's causing some errors. Hardhat Waffle is used for testing, and for this example, we're not going to be writing any tests. Inside the terminal, I'm going to type emb $parentheses cat.emb. This will load the environment variables from .m file, and then we'll type npx hardhat run -- network robston. And the script that we're going to be running is scripts deploy box b1.js. And our contract was deployed to this address. Now this is the account that I used to deploy the upgradable contracts. And if I scroll down to the transactions, you'll see that it sent 3 transactions. These 3 transactions deployed 3 contracts. The implementation contract, so this is our box contract, which we have not verified it yet, and we will do it later in the video. The proxy admin contract, this is the admin to our proxy contract. And our proxy contract. Zeppelin provides 2 kinds of proxy contract, transparent upgradable proxy and UUPS. For this example, I'll be showing you how to use upgradable contract using transparent upgradable proxy. So one of the contract that was just deployed, our implementation, this is the box contract and it is not verified yet. So let's go verify this contract using Hardhat. The first thing that we'll do is copy the address of this contract. So I'm going to scroll up and then copy the address of the contract. And then back inside the terminal, I'm going to type emb $cat.emb npx hardhat verify. The contract lives on Robston, so it'll be network Robston, and then the contract address that we just copied, and then hit enter. Our box contract was successfully verified, so let's go back and check on EtherScan. So back inside EtherScan, I'm going to refresh this page, and notice that the contract is now verified. So recall that we call the function initialize and set bow equal to 42. So if I go to read contract and click on bow, it is equal to 0, not 42. This is because we're not using the storage of this box contract. We're using the storage inside the proxy contract, but executing the code inside this implementation contract. So if you go back to our proxy contract, this is where our bow is stored at, and it should be equal to 42. But if you click on read contract, notice that we cannot query for bow. So to be able to get the value of bow, we'll need to tell EtherScan that this is a proxy contract And we also need to tell where the implementation contract is deployed at. To do that, we'll click on code. And over here, we'll click on, is this a proxy? You'll come to a page saying proxy contract verification. Scroll down, and then we'll click on verify. We'll click on save. We'll go back to a proxy contract and refresh the page. Now notice that it has some extra tabs. Read as proxy and write as proxy. Click on read as proxy. Scroll down, and notice that we can query val. Click on it, and it is equal to 42. This shows that the value 42 is stored inside the proxy contract, but to set the value to 42, we had to call the function initialize, which is inside the box contract. This code was executed inside the box contract, and the result was stored in the proxy contract. The next thing that we'll do is upgrade box to box B2. Notice that for box, it only had the function initialize, and for box 2, we added a new function to increment val. So let's write the script to upgrade from box B1 to box B2. Inside scripts, I'm going to create a new script called Upgradebox b2.js. And again, the first thing that we'll do is import ethers and upgrades from hardhat. Next, we'll set the address of the proxy contract. This is the contract that stores the value 42. Again, we'll write a main script and then execute it. First, we'll get box b2 contract by calling getContractFactory from ethers.js. To upgrade the contract from b1 to b2, we'll call upgrades.upgradeProxy, passing in the address of the proxy and the contract b2 that we're going to be upgrading to. Once that is done, we'll console log box upgraded. Let's now run the script. I'll open the terminal and then call the script emb $parentheses cat.emb npx hardhat run. We're going to be running this script on the Ropsten test network, so network Ropsten. The script to run is scripts upgrade box b2.js. Now sometimes when you type in this command, you'll see an error saying transaction underpriced. So you'll have to retry running this script multiple times. So I'll try running it again. And our box contract was upgraded to version 2. Back inside Etherscan, the account that I'm using sent 2 transactions. The first transaction was to deploy the new box b2 contract, and the second transaction was to call upgrade on proxy admin. You can see here that the first transaction deployed the box b2 contract, and we now have a function to increment the value state variable. And the second transaction called the proxy admin and called the function upgrade. This function upgrade called the proxy contract to update our implementation from box B1 to box B2. Inside the proxy contract, once we updated our implementation, we'll need to tell Etherscan to point to the latest implementation. So we'll do that again by clicking on is this a proxy and then going through the steps. Once that is done, we'll go back to our proxy contract. Back inside our proxy contract, I want to call the function inc, so I'll click on write as proxy, and I'll connect my MetaMask so that I can call the function inc. Once MetaMask is connected, I'll call the function inc. Once the transaction is mined, I'm going to go back to read as proxy to check on the value of val. I'm going to refresh the page so that this val will be up to date. Previously, we had val equal to 42. We called inc, so now our val should be equal to 43. And it is equal to 43. This was a simple example of how to write upgradable contracts and then actually upgrade it using Open Zeppelin tools. In the next video, I'm going to talk about some of the unsafe things that you can have inside your upgradable smart contract. And in the last video, I'll show you how to write a ERC20 upgradable contract. See you later.